Sure. Thank you so much, Eric. Before we do that, I just wanted to kind of comment on what Eric said. It's very always rewarding to see different flavors of Data 8 and how this class has been adopted and has grown on different campuses. So I'll just quickly introduce myself. So my name is Kseniya. Some of you might have had a call with me in the past few years. I am a global adoption team lead, and our team focuses on building this community of data science educators, and this workshop is one of the byproducts of that. I'm personally have just graduated from UC Berkeley, and I'm currently pursuing a master's degree in information and data science at Berkeley as well. And I'll quickly popcorn to Alan so he can introduce himself before we jump into our presentation.
Thank you, Kseniya. Hi, I'm Alan. I just graduated with my master's from UC Berkeley in computer science. But before that, I also graduated with my undergrad from UC Berkeley studying computer science and economics. I've worked with Eric and Kseniya and at the Division of Data Sciences and now CDSS for the last 3 years, starting from the first workshop back in 2018 till now. I've also been a Data 8 GSI for a couple semesters, as well as for econometrics.
Beautiful, thank you. So I'll get us all started on the presentation. Can you see it well? So, can you guys see? Okay, I would assume yes. Beautiful. So what is this survey that we're presenting today? Over the spring semester, we decided to reach out to our potential adopters, people who have mentioned previously that they want to adopt Data 8 in one capacity or the other, and ask them some questions about how the course is running, what infrastructural and pedagogical decisions they have made in order to run this course successfully. We reached out to 126 institutions, and out of them, about 53 replied and let us know what they're doing with the course. So this presentation will be mainly focusing on the 32 institutions that have either run the course already or are about to teach it right now and already had some materials to share. So as for the institutional demographics, a lot of colleges from the survey responders were located either in the West, mostly in California, or in the South, including institutions in Maryland and Texas and Georgia. We also had some institutions in the Midwest, Northeast, as well as some international colleges and organizations. As for the type of the institutions, most of our survey responders were predominantly from four-year colleges, but we also had some representatives from two-year colleges, high schools or below, meaning high schools and middle schools mostly, and other organizations. The other organizations were all some kind of educational nonprofits, either running the courses or creating the materials for other colleges. As for the individual demographics of our responders, a lot of them were from either CS departments or math and stats departments at their schools, but we also had some representatives from the departments of business and economics, data science and information, as well as other sciences. Those would mostly include in biology and other life sciences. As for the roles of our responders, 56% of them hold some kind of position of a professor. Those might include associate professor, teaching professor, assistant professor, depending on their school. 6 of them were holding a position of a chair, department chair, or a dean at their respective institutions. And the other 6 were instructors. Those would include lecturers, teachers at schools, and also instructors at community colleges. As for the teaching status of the course itself, 38% of our responders have taught the course before, meaning that they have completed at least one full semester or quarter before filling out this survey. For the first time teaching survey responders, we had 11 of them. Some of them might have completed the course already by the time this conference is running. And 9 of them were scheduled to teach the course in the upcoming semester and were able to share some of the information with us already.
I'll talk a little bit about some of the course demographics. So out of the courses that were surveyed, the course sizes really ranged all over the place, between 5 in the smallest case to 315 students per semester. And the bar chart below sort of shows the 4 different bins from 0 to 20, 20 to 50, 50 to 100, and 100 plus students in the course. And you can sort of see that we saw a little bit of each bucket in our survey. Most of the classes were taught on the semester schedule, which I suppose really reflects that it's the more popular structure amongst higher education organizations over the quarter system. Most classes also didn't require a prerequisite, just like at Berkeley, but a handful did. And typically, if they did, it would be something like a high school algebra level course or a basic programming course, typically in Python or R, or an elementary statistics course on the level of AP stats or intro stats. Lastly, 82% of our survey respondents found that the course difficulty was just right, which is affirming for a class that is designed to be largely accessible to all. That being said, some did say that they found the course content to be a little bit too advanced. Next slide. Perfect. We also asked survey respondents what the goals they had in offering a course at the level of Data 8. And one instructor and department chair at a California community college noted that it was to provide the first data science course that could articulate to four-year institutions. So their particular goal was mainly articulation focused in offering a course like Data 8. For a professor at a four-year liberal arts college, it was to use this as a cornerstone to help develop a data science curriculum, specifically a minor. And this is often a theme we see in adoption to use to start beginning offering a data science course like Data 8 as sort of this first course in building out an entire data science curriculum for a certificate or a major or a minor. Lastly, another lecturer at a university in Europe mentioned that it was to help establish a data science basis for psychology and research methods. So this is another use case for offering a course like Data 8. It is to help students apply data science knowledge in a particular domain and utilize these data science skills to help to complement that particular domain.
So we also were interested to learn about the topics that the instructors were able to keep or drop. So as for the augmentation of the course material, the additional topics that were commonly included were spreadsheets and databases, as well as some information about other packages and languages. Some of the courses added pandas or SciPy to their class material. Some courses have also added EDA, which is exploratory data analysis and visualizations, some information, some lectures on data ethics. Considering the fact that some of the at the junior or senior level, as well as an introductory course for the master's program, some added further regression, machine learning, and optimization. We're happy to see that some of the courses were able to incorporate open-ended projects, as well as some information about data storytelling at their institutions. As you can imagine, since some of the courses were taught on quarter system or required a smaller unit count, some of the topics must have been dropped. Those were commonly included in classification or either other final lectures in the course, in the traditional Data 8 course. Some opted out from more advanced data manipulation methods. Some have skipped statistics and bootstrapping fully and made it more into introductory computer science or introductory Python course. And some needed to drop visualizations and histograms.
Regarding course infrastructure, most of the classes, to at least my surprise, was hosted on a Jupyter Hub of some sort. So this was often through the 2i2c Hub, which you may have heard a little bit about on Monday, or through their own Jupyter Hub instance, typically through TLJH, which stands for the littlest Jupyter Hub, a relatively pain-free way to install Jupyter Hub. If instructors were not using Jupyter Hub, then Google Colab was a pretty popular option as well as local installations, so typically through Anaconda. So these are some of the other options that courses leveraged to help deliver Jupyter notebooks to do assignments. Regarding learning management systems, I suppose this is sort of a representative sample sort of the learning management system market shares out there. Canvas was the biggest player at about nearly 50%, followed by Blackboard with about a fifth to a fourth. Some use their own website to help deliver content. So this is sort of the Data 8 style, where you have links to every single assignment and lecture. And lastly, some also use Google Classroom to help distribute assignments as well. Half of the courses surveyed did not use an autograder, so they resorted to using by hand, which I suppose isn't too much of an issue, especially if your course is a little bit smaller. But out of those who did, about half of the courses who used an autograder did use Otter. This is followed by OKPy and other derivatives like Gopher Grader, which is something we used, and other derivatives such as the U.S. Naval Academy's is a SEAL grader. And also some used MB Grader as well. So it's good to know that most of the grading solutions that are being auto-grading solutions that are being used are all open source. Some suggestions from our adopters. There were a lot, but so we've really only just handpicked 3 of them. One instructor didn't really like the fact that we featured a significant amount of coding, especially in the KNN, under the K nearest neighbors section of Data 8. And that they thought that it really should be, it was really necessary and laborious, and that it should be abstracted away. And so they ended up using scikit-learn instead, which definitely makes a lot of sense. Another instructor would like to introduce an index to the textbook in order to more easily find topics or examples that they couldn't quite locate. And this is definitely a good suggestion, and it's something that we will be looking into. Lastly, one instructor noted that parts of the textbook were simplified for the audience in order to optimize for accessibility, but that references, or links to more advanced and optional resources or readings could be really helpful for those who do have the technical, or I guess the chops to be able to understand it. And lastly, moving forward, most instructors surveyed would like to adopt Data 100 and or Data 140, which is the probability course, as well as Data 102. Another instructor noted that as a community college, that they would be interested in hearing whether it would make sense to have a second level course with some of the Data 100 material. And in fact, at UC Berkeley, we actually have recently piloted a capstone-like course as a student-run decal course that teaches more industry-oriented skills like Pandas and EDA. It concludes with a final capstone project of the students' choosing. And I believe we will be presenting this at one of the lightning talks later today or tomorrow. So make sure to check that out if you're interested. Another instructor noted that it is time for that leadership to move, that Berkeley has been at the forefront of building an inclusive and welcoming community of data science educators. But it is now time for that leadership to move from building all the materials to curating and guiding the community in its efforts to expand on Berkeley's initial efforts. And I think that's a really good point. And specifically, one focus of our workshop this year has been to host a diverse series of panels with speakers from a variety of different institutions, and help provide a spotlight on other exciting initiatives that are really going on beyond at just UC Berkeley. And we hope this can help foster a robust community in data science education going forward.
Thank you, Alan. That will be it for our presentation, but we move on to giving the floor to our other presenters. I'd like to mention a few housekeeping items. First of all, for our speakers, when they're presenting, it's really hard for them to see the chat. So if you want for your questions to be addressed, please put them in the Q&A session, and we'll get back to it after everybody has presented. And with that being said, I am extremely excited to present our first speaker, Thao-Nhi, who is a community college instructor. She teaches mathematics and statistics at Arundel Community College in Maryland. The floor is yours.
Thank you, Kseniya, and thank you. Many thanks to the organizer for the opportunity to share my experience teaching this first data science course at my community college. I'm going to proceed by sharing my screen. Please let me know if you can see them. How does that look, everyone? Bigger? Very good. Please let me know if you can see my slides okay.
It's all good.
Okay, so the course is Math 285, data science for decision maker, and it is an adaptation of Data 8 that I ran at Arundel Community College in Arundel, Maryland. I taught it for the first time in the spring semester of this year. This course was supported by the U.S. Naval Academy and a grant provided by the Office of Naval Research. The principal investigator for this grant is Will Travis, professor of mathematics at USNA. So I'd like to talk about my adaptation of Data 8 in 3 parts. First, I'll tell you how I got involved with this and what I did to prepare for the course. Then I'll talk about some details of delivering the course in spring 2021. And finally, I'll make some comments about the course looking back from now. So my involvement in Data 8 adoption was through Will Travis's USNA and ONR. In spring of 2020, Will Travis reached out to me to collaborate on a grant to be funded by the Office of Naval Research. Will was looking into data science course at a community college for the Navy. So Will asked me if I could pilot a data science course at my community college neighboring USNA. This would be the first data science course at our college and maybe the first to adapt the Data 8 curriculum at any community college in Maryland. As far as my previous knowledge, I have worked with some data over the years, but I would not have called myself a data scientist. I have been teaching mathematics and introductory statistics for a while, so I felt okay about my math and basic stat background. And I had been learning some Python programming for a little while recently, mostly just for fun. So to prepare for the course, I started prepare in summer and fall 2020. I attended the 2020 National Workshop on Data Science Education, this same one, but a year ago. This conference was incredibly helpful for me. Through this conference, I met Eric and Kseniya. They helped me with questions about course preparation, and they also provided me with access to Data 8 course material. I talked with Will Travis about various topics in the course in my preparation time, including cloud computing, some statistical topics and ethics. And we decided not to use cloud computing after all. So I asked some of my students to download and install Anaconda and use Jupyter notebooks on their personal computers. We also wanted to make sure students had a good way to organize and manage files. I learned this from Will. The file management can be complicated for students who are new to this. So I test this whole process out with a few volunteer students in the fall to prepare for the spring course. In the fall of 2020, I hosted a workshop and invited some of my colleagues who were interested in the course. We went over the whole process of software and library installation and worked through some labs from Data 8 and some from Will's course. This process was really helpful as a practice run for me. So as I prepare for the course, I made some changes in the homework and lab and lectures to make it more relatable to my students. For example, I replaced Cal football data with Baltimore Ravens data. I replaced farmers market data in the Bay Area with farmers market data in Annapolis, Maryland. Bay Area bicycle rental data with DC metro area bicycle rental data. You can see a similarity and difference there. I changed the airline data out of San Francisco with airline data out of Baltimore. And I also added some data set that I found interesting. For example, I used a data set with real estate listing in Sao Paulo, Brazil. And I also replaced, I think, UC Berkeley faculty salary data with diversity data for school enrollment across the country. So swapping out these data sets require, from minor to moderate changes in the corresponding homework and lab questions. So it was a great way for me to get a strong understanding of the assignments. So that was very helpful. As far as auto grading go, I used the auto grader from a program that was written by Will Travis. He called it CO Grader. It works locally, and you run it in a Jupyter notebook. This was a perfect setup for us, but it took some time for me to learn how to use the tags in the Jupyter notebook to prepare for homework assignments, for auto grading, homework and lab assignment for auto grading. As far as course section go, we offer this course as a special topics course, which only counted as an elective for math majors. So we started with one synchronous section. Some student reached out and they wanted to take the course, but they had schedule conflicts. So my assistant dean and dean were very supportive of this course and of the students. So they were happy to accommodate these students. So I ended up taught two sections, one online synchronous and one asynchronous section. As far as course schedule go, I mostly followed the Berkeley schedule for the class with a few changes. We had 2 midterms exam and a final exam. I added a day for discussion on ethics and data science near the end of the course. And my goal there was just to get students to start thinking about ethical issues and data usage, just to begin to think about that. In terms of course delivery, one big difference between my course and Data 8 was that Data 8 was a 4-credit hour course, but mine was a 3-credit hour special topics course. We had no lab hours and no lab support for students. I had 6 office hours each week, and I usually spent at least that much time, often more, to have discussion with students just from this course. It sounds like a long time, but as you discuss student time, just kind of fly. We had a lot of fun, even though it took a long time. Outside of my office hour, though, students worked together in a virtual tutoring lab environment. And although that was a developmental math course, math lab, I say, our lab manager still welcomed them there. She attended every class, helped me with my office hours, and helped my students by organizing them into breakout rooms to discuss questions among themselves. And when she was free, she joined them for discussions as well. As far as my synchronous section go, I recorded video for students to watch. There was one video for each day of instruction. So I had 3 per week. The videos range from 15 to 40 minutes, but they took a long time to record. And some are in dire need of improvement. So I'll get to that later on when I have time. I also wrote short readiness quiz, one for each day of class. So these were very short quiz, 3 to 5 questions, true, false, multiple choice, short answer. They were designed to motivate students to look over the material before we covered in class. One thing I also found helpful was a conversation with El Camino Community College DS team. So during the semester, I reached out to Solomon Russell at ECCC. He's part of the team teaching a Data 8 adoption there. You might have seen him on the panel here this past Monday. Conversation with him, Alice Martinez, Chin John, and their student, Topher Allen, were very helpful. It was great to talk to others teaching the same course at a community college. Well, also one great thing that came out of this, thanks to Topher and Kseniya, was that our students collaborated together and organized the first community college data science conference in May of this year. They had about 600 registered for the conference, I think, and I'm really proud of their collaboration and efforts on this. So to finish here, I like to share some thought I had about the course, and now that we had completed one trial run. In terms of my student feedback, my students really enjoyed the course and the material. Thanks to the author of CIT for doing the hard work. They also like the ethics discussion with one another. They want a separate lab hour in addition to my office hour. Well, I also realized early in the course that both my students and I needed more time. So this really needs to be a 4-credit course with lab hours and support staff. In terms of time spent grading, the auto grader really helped, but grading still took a lot of time. There are short answer questions and lots of questions involving random sampling that I was not able to auto grade. So I manually grade all of these questions. And for many of them, I debug student code so that I could provide meaningful feedback. My students really appreciate the feedback, by the way. But if we had additional lab hours for the students, I might not have felt compelled to provide all of this detailed feedback. But without it, the student had no way of knowing whether they did it right or wrong. So this is another reason why we need a 4-credit hour course. Projects, we could not offer any project because we didn't have any time. But if we can offer this as a 4-credit hour course, I'd like to include some project for sure. And I'd like to share some great news in terms of internships. As I was teaching the course, I encouraged my students to apply to some data-oriented internships. Several students applied and were accepted. Now, I cannot say that they got this internship because they took the course. They can't prove causality in this case. But they were definitely more confident in their application. I think it is because of their familiarity with the ideas of using data. Not just for these students, but for other community college students in the future, a course like this provides a great path for them to apply for some internships and jobs. Students without a background in computer science who take this course have a shot at some opportunities they might not have even considered before. So I think this is a great course for community college as well. And that's all for my presentation. Thank you for your attention. If you have any questions, please feel free to put in the chat and I'll get to that. Thank you.
Thank you so much, Professor Luz. Thank you for sharing your experience of teaching Data 8 at Arundel Community College. We do have some questions directed to you in the Q&A session portion, I guess, of the session. We can get back to them later.
Thank you.
And we'll move on to our next speaker, Professor Ajay Anand from Rochester University. This time last year during the conference, during the workshop, he was actively adopting Data 8, and I'm excited to hear about his experience of doing so.
Great. Yeah. Thank you, Kseniya. Hello, everyone. Very pleased to present our experience with incorporating Data 8 here at Rochester. So let me start by sharing my screen here. Hopefully everyone can see my first slide here.
Yep, perfect.
Okay, great. Yeah. So as Kseniya mentioned, we had one offering of the course. As the title mentions, it was a modified offering compared to the typical Data 8 version. So it was a 2 academic credit version, so a more condensed version. And I'll, in a moment, I'll describe the motivation for that. So by way of introduction, I'm a faculty member and also serve as a deputy director of the Gergen Institute for Data Science here at the University of Rochester. So we are in Western New York, just to contrast from Rochester, Minnesota. And so we've had a series of activities around data science education here at UFR. So before I get to the course, I just want to provide a high-level overview of our program. So we have an undergraduate and a graduate program in data science. It is, as expected, grown over the past few years. We currently have about 150 students in our undergraduate and about 100 graduate students. We also recently launched a graduate certificate program. I'd like to point out that we were one of the earliest undergraduate degree programs in data science in the US when we started in 2016. Of course, a lot has changed now. And interestingly, about half of our students who pursue data science at the undergraduate level are double majors. So true to the spirit of data science, they're combining that with other disciplines. We also have invested quite a bit on experiential learning in our program, mainly through capstone and practicum projects. And as with the enrollment, this offering has also grown over the years. And since 2015, we have offered more than 70 projects from close to 50 organizations, typically in the senior year to our students. So coming to this specific course, this course was titled Introduction to Data Science. As Kseniya mentioned, right around, it was held in the summer of 2020. So a year ago at this time, we were actually planning for it and preparing for it. In the midst of the pandemic, given the scenario, it was a completely virtual offering. And really the motivation, this had been in the works, but it was catalyzed by the opportunity that the summer provided in terms of providing an online offering. It was really motivated by the interest to offer an introductory course to undergraduate students across the campus. So in our data science program for our majors, we have typically had introductory courses that are derived from computer science. So they do introduction to programming, they do data structures. But this was really a way to provide a broader introduction to data science to students across campus as well. So coming to what motivated the 2-credit version as compared to standard 4-credit, which is where we hope to go soon, it was really the limited time frame we had, and both in terms of the calendar time and also the time allocated that would have been possible for contact hours. So that forced us to plan a 2-credit version. As a result, we decided to emphasize, some of the key activities that would help students as part of the course to get experience with the data science workflow, basically to understand some of the key concepts and also to get familiar with some hands-on activities. So as a result, the decision to offer the course and both the preparation time that we had for the course happened on a pretty rapid timeline. Again, as Kseniya mentioned, it was towards the end of spring, early summer, leading into early July when the course was offered. That's sort of the effective preparation time we had. And quite frankly, this wouldn't have been possible without support from Data8 and the team at Berkeley to offer this on such a rapid timeline. We had a modest enrollment, given this was the first offering with kind of a limited time to really get the word out. But we had about 20 students, and as you can see here, it was really a diverse class. So we had undergraduate students. We also had some very enthusiastic and interested high school seniors who were actually rising first-year students here at the U of R. And also a few university employees who were very new to programming and had an interest in data science. So, like I said, this was the core of the course was based on Data8. We specifically used the spring 2020 version as a reference to develop the course materials. We made some changes based on really accommodating into the 2-credit version. So this involved dropping some topics, and these were based on discussions we had around what would appeal to this audience. So here I'm listing all the topics here, and essentially the theme in terms of what was dropped would be some of the advanced topics in data manipulation. And also some of the advanced concepts within the Python programming. So, for example, we didn't have a chance to touch on loops, which would lend themselves to more some of the advanced topics. Also, when it comes to some of the statistical emphasis, we did not have topics around bootstrapping, p-value evaluation, and so on and so forth. So some of the advanced topics and statistics were not covered, but to kind of within the theme of providing more of a hands-on experience, we did introduce some emphasis around topics on data visualization. And this is probably where we deviated from Data8 a little bit. We actually had students get access to Tableau as a data visualization tool and then do some activities in Tableau. For the Tableau exercise, I was actually able to leverage a pre-college course that we had done in the previous year, and so that helped with the preparation as well. We also wanted the students to get just an introduction to classification, so we had a couple of lectures devoted to that. Again, we didn't have a chance to go into the level of detail that the typical Data8 curriculum offers for that topic. Just to make the online experience engaging, we added this segment called Data Science Example of the Day. So this is a short segment at the end of each lecture. We try to take some real-world event. So that in 2020 it was mostly COVID-related examples, and basically present a visualization or interesting dashboard, and then describe some related analysis. As you'll see in a later slide, this definitely piqued a lot of interest from the students. So in terms of course organization, it was really the instructor along with one TA. Sorry, I say TAs, but there was just one graduate student TA. It's a master's students in data science. We did not have a chance to use a cloud-based version, so we basically had all the students download Anaconda with Python, using Python, just like Thao mentioned in the previous talk as well, and we also relied heavily on the data science package. So we used the data science package as the basis for students to get through the exercises in Python. We made sure that the installation was across this group of students. The installation was seamless, making sure each of them had the installation in place. We offered additional TA support hours during the first week in order to ensure that. And then following that, every week between instructor office hours and TA office hours, that was a prime basis to assist students with the Python programming, in addition to going through the hands-on examples during the class. We had an assignment during those 6 weeks every week, and the students were submitting it via our LMS. So Blackboard is what we use here. We used the Jupyter Notebook, and they were also submitting. We encouraged them to submit the PDFs as well to help with the grading. At the end of the course, we had a take-home project. So that was essentially to develop some visualizations, do some analysis, and then communicate that back as part of the submission of the project, and also had an asynchronous take-home exam. Again, these were kind of adapted, keeping in view the kind of the online format that we were doing last year. We did not have a chance to use AutoGrader, but given the enrollment in the course in the first year, we were able to manage that quite well with a manual approach. So I just want to share some feedback from our first offering. Overall, I would say the feedback was positive to the content and the organization. The students appreciate the format and also the ability to get a kind of a hands-on and high-level understanding of what data science is. Having the opportunity to use Python and sort of go through the exercises and so forth. There were a couple of students, again, as I said, the class audience was quite diverse. So there were a couple of quotes from students where they probably would have benefited from some more hand-holding around the coding exercises, because we had to cover the coding very much in the initial week so that we could use that, in the later parts of the course. So one of the takeaways is to provide maybe more of these workshops early on to be able to help students to get more comfortable with the coding segments. As also mentioned by the previous speaker, there was a preference for localization of the data set. I think I got some inspiration from the examples that was mentioned by the previous speaker. We will probably have to customize and use more like Buffalo Bills data sets and so forth to make the students relate to the content better. But for this offering, we were using the baseline. So we had all of the default examples from the Data 8 curriculum. And also, I was glad to see that the concept of providing a data science example of the day was well received by the students. So if we were to look ahead, clearly the 2-credit offering was customized and designed specifically for the summer. It's something that we plan to continue to offer over the summer, but our goal really is to formalize this and make it a 4-credit offering. And once it's a 4-credit offering, it can be more seamlessly incorporated into the major itself. So just to clarify, at the moment, the way the first version was offered last year, it would not count to the data science major. It was more of an elective or something that a student could petition to add to their major, and not necessarily in data science itself. So they could do that across other disciplines as well. The other is as the enrollment grows, of course, we would have to look at optimizing the grading and programming infrastructure. A lot of the best practices that are in place is something around Jupyter Hub, and also the auto grader using Otter is something we would look at. Basically, that's the way we think the scaling of the course would also be feasible. Like I mentioned before, additional TA sessions, workshop sessions for students who need additional help is something that would be something we would incorporate going forward. And again, this course also served as a good motivation for us to consider a data science minor, something that we have been discussing within the group, within the department, and this course clearly would be a key component of that. We also plan to, of course, when we expand to the 4-credit version, we plan to augment some of the topics, bringing back some of the topics that are in the core Data 8 curriculum, and also enhancing that with topics around ethics and privacy as well. Last but not the least, I do want to acknowledge some of the key people who are here and who without whom this wouldn't have been possible in that short time frame. So around this time last year, Eric, Kseniya, and Anthony were instrumental in pointing me to the right resources, making sure that I had the content that would be needed to provide this first offering. And quite frankly, without that strong support, it wouldn't have been possible to offer this in that compressed time frame. And I also want to acknowledge the support, the portals that are made available for teaching Tableau, and some of the case studies and examples that are provided through that portal. And the combination of these two is what helped make the course feasible. Also, I want to give a shout out to Kseniya. We had a write-up about this course in the data science newsletter in one of the recent issues, and really acknowledge Kseniya's support in pulling that together. So that really wraps up my presentation, but happy to answer any questions about this specific offering when we have a chance after the presentations. So thank you all. Thank you very much, and look forward to the Q&A.
Thank you so much, Professor Anand. Thank you for sharing your insights on teaching Data 8 as a 2-unit course. And we're off to a representative from UC San Diego, who were one of our first adopters of Data 8, I would say. Justin Eldridge is an assistant teaching professor in the Data Science Institute at UC San Diego. Justin, the floor is yours.
Thanks. Okay, can you see my screen?
And it's working fine.
Awesome, great. Oops. Okay, yeah, so hi, I'm Justin Eldridge, assistant teaching professor at UC San Diego, and as Kseniya mentioned, I've been at UCSD for 3 years, and we've been teaching this course, DSC 10, which is our kind of iteration of Data 8 for 4 years now. So to give you some context, our undergraduate data science program has both a major and a minor. Last I checked, we have about 800 majors and 200 minors, but we're expecting the number of minors to actually grow quite a bit over the coming years, maybe even eclipsing the number of majors that we have. The program is about 4 years old, and at this point, most of our courses are now in-house in the sense that we've created our version of, for example, machine learning courses, mathematical foundations, and so forth. So the major does consist mostly of data science classes that we have control over. So DSC 10, as I mentioned, is our adaptation of Data 8. It's the first year, meaning that whenever our majors come in, fall quarter of their freshman year, they're usually taking DSC 10. Transfer students often take this their first quarter at the university as well. But we've seen that DSC 10 is very popular with non-majors as well. I looked at the last offering this quarter, and we had sizable representation from economics, from management science, biology, marine biology, psychology, international studies, and so forth. And when I teach this class, sometimes we'll get graduate students in the class. who just want to kind of brush up on, computational statistics. So we get a very diverse population. So some more context. As I said, DSE 10 is sort of the first course, the intro in our program. There are no prerequisites for DSE 10. There are no mathematical or programming prerequisites. After DSE 10, we have a class that focuses just on Python. So that's called DSE 20. It also covers some data structures. And then we have a class in Java, which focuses on data structures. That's DSE 30. So after they take DSE 10, they get in-depth training in programming in particular. And then generally in their sophomore year, students will take the theoretical foundations sequence, mathematical foundations in 40A and algorithms in 40B. And then all of this is kind of tied together in what is kind of like a cornerstone of our curriculum, practical data science in DSE 80. So DSE 80 is a course that I actually just taught for the first time this quarter. It's a lot like DSE 10, but now things are messy. In DSE 10, the data is nicely curated for the students, so they don't have to worry about missing data, getting data from the internet and so forth, which is absolutely necessary, the first time that they're seeing data science topics. DSE 80 is kind of like, okay, this is what we do in practice when we have missing data and so forth. And so I've heard anecdotally that after DSE 80, something like 60 to 70% of our students are able to get internships. And so we feel that this is a very important course. And so I kind of draw parallels between 10 and 80. 80 teaches pandas, sklearn, and various other tools that are used in industry. And then, of course, we have the upper division, which has machine learning, probability, and statistics, and so forth. And then we end our curriculum. So as far as what is in DSE 10, the topics stick mostly to what is in Data 8. One difference is that at UCSD, we're on a 10-week quarter system. We generally teach DSE 10 in the summer as well, and this summer we're doing it in 5 weeks, so it's a condensed version. The first half is an introduction to Python. We assume no programming background whatsoever, and an introduction to working with tabular data programmatically. And the second half focuses on statistics via simulation.
Justin, can I interrupt you for a second? It looks like your slide is not changing for us.
Oh, I'm sorry. What's the last slide you saw?
The very first one.
Oh no, that's no good.
There we go. Yeah, now I can see it.
Let's take it out of full screen mode and okay, so let's see. I don't think there was anything super important here. Okay, so here's where we are. So as far as the syllabus goes, we kept some things that I saw that others had removed, the bootstrap, confidence intervals, regression, the central limit theorem. We removed classification. That's covered later in DSE 80. As far as the technology that we use DataHub, which is the UCSD hosted version of JupyterHub. We use AutoGrader, and one small kind of implementation detail that we made early on was to recreate slides using Jupyter Notebooks, using a package called Rise, which allows you to turn a Jupyter Notebook into a slideshow. So a lot of our lectures are kind of like live coded, where we have the outline in the Jupyter Notebook, and then we'll write the code in the notebook itself, and it presents as a slide to the student, but then the student can download the notebook and then they have it for themselves to follow along with. So the main difference between our iteration and Data 8 is that while Data 8 uses the data science module, we teach pandas. And I'll talk a little bit more about this in a second. We actually use something called baby pandas. So this leads to the question, why make this change? And there are trade-offs here. It's not necessarily clearly one is better than the other. But we felt that pandas was a better fit for our particular curriculum, especially because of that class DSE 80 that I was mentioning before. DSE 80 is all in pandas. And so we felt that once students got to DSE 80, we were spending time teaching them to use a new data science package that maybe we could save some time, streamline things by teaching pandas early on in 10. Part of this was motivated by student feedback. Kind of the more advanced students who knew about pandas would get to the end of DSE 10 and write in their feedback, why aren't we learning pandas? Internships, so students going out into industry or doing internships early on, we wanted to give them the tools to be able to pick up work on day one. And there are more resources online for pandas. One of the things we like to encourage our students to do is read the documentation. Throughout our lower division, we say, you can use whatever tools you want, just make sure that you are reading the documentation and understand. And so with pandas, they can go on Stack Overflow, and maybe that's a bad thing, see some sort of incantations for doing whatever they're trying to do. But why not pandas? Well, pandas is kind of an organic API which grew over time. It can be confusing for those new to programming. And so this is the strength of the data science model of Data 8, right? Because it presents a much nicer, cleaner interface, which allows students to focus more on the principles than on, like the particular syntax and the weirdness of pandas. So the way that we've addressed this is by creating something called baby pandas. And so when I say we, I mean Aaron Frankel and Darren Liu, with a tiny bit of help by myself. Baby pandas is a nice subset of pandas. So it's literally a selection of methods and functions and classes from pandas, which presents a canonical endorsed way of doing anything. So it's implemented as a thin wrapper around pandas, and it's hosted here at this GitHub. So the philosophy of this is that we're trying to encourage best practices, immutability over mutability, and try to present one way of doing things. Pandas, there's famously many ways of doing the same thing. With our subset, baby pandas, there's generally one way to do anything. And it also allows us to give nicer error messages because we wrap pandas. We can say, oh, you're passing in something of the wrong type here. Give something a little less cryptic than pandas would, which is very important for people learning, for the first time. And we strive to be 100% compatible with pandas, so students can say on their resume or their application to an internship that they know pandas, because baby pandas is pandas. It's just a small subset of it. So if you go to the GitHub repository, there are some examples of how we differ from the data science module. The left column is the data science module. Sorry for the sirens. The left column is the data science module. The right column is baby pandas, which you might recognize as being essentially pandas. We do some things differently than maybe the canonical way of writing pandas. For example, getting a column, we use the get method because it returns a copy instead of a view into the data frame. That's where we strive for immutability over mutability. Switching to baby pandas means that we have to write a new textbook. So we've been writing a new textbook calling Dive into Data Science. So when I say we, this is me and an undergrad, Parker Addison. And so it's at diveintods.com. And it's topic complete, but it's a work in progress. So you might see things change. So some observations from teaching DSE 10 over the last 3 or 4 years. The biggest challenge I see is the bimodal distribution in our students. So this is not a new challenge. Computer science programs have seen this forever. But if you look at the grade distribution in DSE 10, it's literally bimodal. You have a group of students who had programming experience, and for them the class is too easy. That's some of the feedback we get. They say it's too easy. And then for the students who have no programming experience, the first half of DSE 10 is not enough. The way we kind of teach programming in DSE 10 is kind of like by teaching just enough Python to do the data analysis. But what we find is that for students who don't have any experience in writing something as syntactically rigid as a programming language, it's a jarring experience. And so what happens is we go from DSE 10 to DSE 20, which is a class which focuses on Python, and we get a lot of feedback from those students who say that this is a huge step up. This is too hard of a transition. So the feedback we get is also kind of like stratified into, some people say it's too easy, some people say it's too hard. And so, thinking about solutions to this, we have weekly programming kind of tutorials that are optional for people who want more support. But the fact that that's coming in the middle of the quarter seems to be a challenge for a lot of students. So we're thinking about ways of getting that support to them before DSE 10, maybe an optional course that focuses just on Python taken in the summer before they join UCSD, or maybe rearranging the curriculum so that something like a Python class comes before DSE 10. So those things are still left to be decided. But I'm happy to answer questions in the panel that follows, or send me an email if you'd like.
Thank you so much, Justin. We'll move over to Q&A session after Adam. And Adam Poliak, when we met him, he was still a PhD student at Johns Hopkins University, already preparing to teach his first course at Barnard College. So, Adam, floor is.
There it is. Awesome, yeah. As I tell my students, it doesn't matter how old you are. Once you become a faculty member, you become technologically inept. So I think that was a good demonstration of that. And thank you for the introduction, Kseniya. So I have the chat up, not the QA. So if anyone has any questions, feel free to type in the chat in the middle. Okay, so I'm going to be talking about my experience adapting Data 8 this past fall and teaching that here at Barnard College. So as Kseniya mentioned, I recently finished my PhD in computer science at Hopkins. We're focused a lot on natural language processing and applying data science to text. I've just wrapped up my first year at Barnard in a 2-year appointment. So if you're an institution that's looking to incorporate data science and introduce more data science courses, I'll be likely on the market next year. I'd always be pitching. So brief overview and background of Barnard College. It's the women's liberal arts college affiliated with Columbia University. So it's its own independent institution, but students can take classes back and forth. So Barnard is one of the original 7 sisters colleges. It's a pretty small institution. It's primarily undergraduates, and there are about 650 students a year. And here are the top 10 most popular majors. So computer science is on there. Computer science at Barnard is new as a major. So traditionally, all of the students at Barnard who majored in computer science took all of their computer science classes across the street at Columbia. Barnard's recently developed a computer science department, but a big mission of this department is also about evangelizing and supporting computational thinking across the college. And as part of the required classes, foundations at Barnard, students have to take a course on quantitative and empirically thinking. So the goal and aim is for students to really get comfortable with how do we analyze numbers, figures, graphs, and really using quantitative and empirical approaches. Another required class that students have to take is what they now call thinking technologically and digitally. And this really is sort of a class in computer science, in digital humanities, digital design. And as a college, Barnard's really focused on bringing computer science and data science throughout the college and really into the students' experience. There's a big data science presence at Columbia as well. So there's a large data science institute that has over 350 affiliated faculty from all the different schools. So if it's Columbia College, the engineering school, Barnard, the School of Medicine, School of Social Work, the business school. So it's pretty large and really fosters a sense of collaboration throughout the broad university. And it's currently led by Jeanette Wing, who wrote the seminal paper called, where she defined computational thinking. And in this course, I had students actually read that to gain insights on what do we mean by computational thinking. There is a undergrad major in data science. It used to be called actually computer science and statistics. I guess with the whole rebranding and popularity of data science, they renamed it to BA in data science. The DSI really focuses a lot on the master's and graduate level, and not so much on the undergrads. That's why there's this large demand for classes like Data 8, and that's what we'll discuss now. The class that I taught in the fall, which is modification and adaptation of Data 8. So here are the course objectives, which are very much in line with Data 8's objectives. I think they're even copy and paste, most likely, from the Data 8 objectives. So in the fall, I taught this as an immersive course. Columbia decided to, in addition to offering 14-week semesters, they offered these immersive semesters. So an entire class was crammed into 7 weeks for the same amount of credits. So we met 4 days a week for 7 weeks. And I had, it took me a while to figure out how to cram everything into this short amount of time. So what ended up being very helpful was just modeling it after the summer version of Data 8 taught at Berkeley, where we didn't have to drop any material, but we just really had this type of plan to condense everything. So students had 2 weekly labs, 2 weekly homeworks, had 3 1.5 week long projects. And instead of a midterm and final, we used the final projects, which were the exact same ones from the Data 8 summer 2020. So I had, oh, where did my slide, where did everybody go? Sorry, let me, right. So I had a really helpful and supportive course staff. So there were about 33 students in the class, and there was 4 of us. So me as the instructor, I had a second year data science master's students, as well as 2, we call them computing fellows, I guess, at Berkeley, like the GSIs. So these were 2 undergraduates, computer science students, and together they helped lead the labs as well as weekly office hours. And there was a lot of interaction between course staff and students. So we met 4 days a week for 75 minutes, and students had 2 50-minute labs. So in turn, we had labs every day, and students could choose which of the 2 labs to attend. Having this, I found this ratio of like 4 of us to 33 really helped us create a lot of support for students. Something that I found was students really picked up on the material well, but their confidence in their skills took a little bit longer to develop. And they definitely appreciated all of this support that we had for them. Thank you, Ross, for sending the link in the chat to Jeanette's paper on computational thinking. So I know a lot of you that are interested in adopting this course. A big question you have is, how am I going to set everything up? That was something that I definitely struggled with for a while. So I used a course Jupyter Hub. I was able to set it up myself. It took me a few attempts, but it was actually pretty straightforward once I found the right documentation, and my TA managed it. We hosted it on Google Cloud using Google Educational Credits. And for those of you who are not in, so it seems like the Data 8 folks at Berkeley run a Slack, and that was very helpful for me. So when I applied for Google credits, I originally got rejected, and there was a conversation on the Slack about what to write to get approved. So that was pretty straightforward to set up. To create the assignments, I used Otter. I'd also recommend you joining the Otter Slack group. Whenever I've had any issues or concerns, people have responded really quickly there. All the assignments, I just used the Data 8 versions. And I made a few more things New York or Columbia centric, like as everyone mentioned. So I used Gradescope for, oh, this thing keeps on going away. So I used Gradescope to collect the assignments as well as grade them. And we also used a Slack for students to interact with each other. I think this was really helpful with the immersive and fast-paced setting of the course. So I'd like to now talk a little bit about the students' backgrounds. Where did they come from? What were their majors? What were they planning and hoping to get out of this course? Right? So as I mentioned, we had 33 students in the course, so it was a pretty small course. And although there were students from the different schools at Columbia, like Columbia College, the engineering school, the School of General Studies, so this is for students who don't follow the traditional four-year right out of high school path, but students primarily came from Barnard College. And students ranged from all different years, so they're a big bulk of junior as well as first-year students. And something that I really enjoyed about this class was that I had students coming from all different backgrounds. Most of them were undecided, so this actually tracked with the 8 first-year students. But really you can see that the students primarily came from social sciences. We did have a good amount of computer science students, and at Columbia, computer science students don't have to take a statistics or probability class. So once we got into inferential thinking, they really learned a lot. So in the beginning of the course, when I was learning how do we manipulate tables, I think a lot of the computer science students were able to follow along and do pretty well at half speed. But then once we got up to inferential thinking, they really had to, were at the same level as every other student, regardless of background. And students' motives for taking the class, so of course there was a lot of students that wrote that they wanted to take the class because to fulfill these requirements. I think it's helpful when we have institutions that have bought in to increasing computational and statistical thinking across the board. A lot of students wanted to use this as a way to explore what does computer science, what does programming look like. And there are students that also wanted specifically to bring data science into their respective fields. And from students' perspectives, which we'll highlight, I think really they hit these goals. So here's from a survey of how much did the course enable you to improve quantitative skills? And we can see that students really improve their quantitative skills through this homework, through the labs, through the assignments. And students really are encouraged to continue on in the data science pipeline. So continue on taking statistics and our computer science classes. So I really think it fed its goal, it served its goal as being a feeder into not only just getting students' appetite wet with data science, but really encouraging them to take more classes and continue exploring data science and applying it to their own fields. So here I put some feedback that students had about the labs. I'm not going to read it. I'll let you read it all on your own right now. But it seemed like the labs really, students really appreciated the labs were a way for them to get more comfortable with the material in a low setting, in a low stress, low anxiety setting. And these were labs that I hardly modified. These are really the content created and developed by folks at Berkeley. I think having a 50-minute lab wasn't so feasible. I had that just because of some constraints within the setup here at Barnard, but I think definitely it when I'm teaching this in person over 14 weeks, I probably would follow the setup at Berkeley of having once a week 3-hour lab. I put some more feedback that students shared. I think these assignments all came from Data 8 and the team at Berkeley, so I think these quotes really are a testament to the material. I never described, as a student, I never described my homework as pretty fun, so I definitely would take that as a major win. It really shows why these are great assignments. Yep. So lastly, so this past semester I taught an extension of Data 8, but we focused on collecting text data and using natural language processing to sort of discover insights from text. So more in line with a lot of the research I do. One way I pitched it is that Data 8 teaches students how to work with tables. So this class, we really focused on how do we collect text and then convert or quantify text into tables so that we could do everything that we did in Data 8, we can now apply to textual data. In the last project from Data 8 that was about classifying movie reviews, I felt was a really good way to pitch students into taking this course after Data 8. Another way that I often pitch this course is that I wanted to take non-computer science students who've taken 1 or 2 programming courses on how to teach them how to ramp up on tools like NLTK and scikit-learn so that they can be dangerous in their own fields. And the students, so I had a wide range of students who took this course. Students primarily didn't take the Data 8 class that I taught, but some did. And I noticed that in the final projects, the students that took Data 8, they all wanted to incorporate hypothesis testing and have successfully incorporated hypothesis testing into their final projects, even though it wasn't something that we covered in the class. And since Justin described it earlier, I wanted to note that, so in this class, students learned how to use pandas. And for a while, I couldn't really find a good reference, a good textbook for pandas. And once I found baby pandas, I was sold. And that was what I had students use to get comfortable and learn pandas. And I could tell then when I'm looking at assignments, which students really used baby pandas because of the way they would do different things within pandas. In this class also, the students dealt a lot with messy data, and I'd be happy to talk about it later. But I wanted to conclude with this quote from a student describing the Data 8 version that I adopted. I couldn't have said it better myself. And I think this quote really shows how students aren't interested in just learning how to code. I remember when I was in school, there was this big phase of everyone needs to learn how to code. I think that led to a lot of ramp up, a lot of increase in demanding computer science classes. But after students take a few CS classes, the CS department isn't necessarily built for how do we have these students apply what they're doing in settings that are useful for them and not necessarily go down the software engineer path. And I think Data 8 really does a great job of teaching students how to code, not only just how to code, but how to analyze data and do science. So I'd definitely like to thank Eric, Kseniya, and the entire team for helping me adopt the course.
Thank you so much, Adam. Thank you for sharing all of this information. I hope it will come useful for future adopters. We do have a couple questions, well, more than a couple of questions in the Q&A, so I'll start reading them out. So for those offering a final project, what was the rubric like? I'll popcorn to Ajay for that.
In our implementation for the credit version, the final project was really a combination of a couple of examples in visualization. So we were basically giving them a data set, and then we asked a few questions about the data set. So that was sort of the guiding rubric. And then what the students had to do is work with the data set, with the tabular data, manipulating that, and then the output would be the visualization and also a question that they can answer from that visualization. So it's, in some ways you could think of it an expanded homework, but I think the creative part to call it a project was really also interpret some of the visualizations and report on that.
Do others have anything to add to the rubric? Okay.
Yeah, I can go. Yeah, for the for the final project, I basically just used exactly what the rubric from the Berkeley summer version, where basically the students were given a data set and asked to propose a and come up with a research question and use the methods to answer the questions. So these were notebooks that they all released that we just released as well. One thing I added was I had students write a pre-registration. So this was where they wrote somewhat of like a formal idea of what they were going to work on. But I think a lot of the questions that we have always just look at sort of what's being done in the Data 8 class, and that's always like where I first go to.
Thanks for sharing. Some of the questions were already replied to in the Q&A. There's one for Justin. Is there any chance that you will share the Baby Pandas library and its documentation?
Last part?
Will you share? Is there any chance that you will share the Baby Pandas library and the documentation for it?
Yeah, it's on GitHub. Yeah, the organization is Baby Pandas Dev, I believe, -dev, and it's the Baby Pandas repository. I'll put it in the chat.
I guess my question is, if there are people who would like to adopt your version of Data 8 with Baby Pandas implemented already, how can they reach out to you, and will you be willing to give this material, share this materials?
Yeah, of course, reach out. I'll put my email in the chat as well. Material going to package, which you can actually pip install Baby Pandas, and the textbook, Dive into DS. And then as far as the materials, we actually, so we kind of develop our homeworks. I think we started using Data 8, the Great Data 8 assignments, and kind of over time have kind of replaced them with our own, just to have some fresh material. And so it's been kind of a smooth change replacing the data science module, which we started with Baby Pandas. But yeah, feel free to reach out. I'll put my email in the chat.
Great, thank you so much. And I was asking, how did you find localizing Data 8 materials? And I'll popcorn to Thao-Nhi.
So I just, everything started with a Google search. And we have Kaggle and some government website, the state website, and I go from there. Bureau of Statistics, for example, give you a lot of data, transportations. A lot of government sites give us all the local data related to our own state and city and county. That's where I go for those.
Thanks for sharing. And Adam, where do you get data when you're trying to localize the assignments?
Don't really remember, to be honest. I think some of the assignments I just would do manually. So like that football example, there's like I can remember one. I don't remember what the assignment specifically is about, but it's all about. But the data is like Cal football. So for that, I just went to Google and found how did Columbia do that year. There was like another one of the assignment on K nearest neighbors. It was like classifying students as whether they go to Berkeley or Stanford, right? Is that the assignment? I think so, right? Based upon their like XY, their like longitude, latitude coordinates. So for that, I think I just made up data and then had them being like Columbia, NYU, or Cornell Tech. And I remember that was a big pain, getting those coordinates right. I think I spent way too long on that. Probably should have sent that to a TA. But yeah, I think a lot of it you just sort of do manually.
Justin, can you talk a little about localizing the assignments as well? If you did.
Yeah, sure. So I found that a lot of medium to large size cities like San Diego will publish data about everything from policing to like water usage, et cetera. So we've used some of that data. For the projects and stuff, so like I'll replace it. There's a data set of like San Diego burrito ratings for all the burrito shops. So I think I've used that. But also for projects, sometimes I won't necessarily localize. One great source for project ideas that I've found is like to go to a journal like Proceedings of the National Academy of Sciences or Science or Nature and see what interesting result people have found. Like Californians are more likely to be like risk takers. Then there's like belief that this might be like passed down from, I don't know, like miners from 1800s or something like this. And so there's like interesting ideas like that for projects. Also 538 publishes a lot of their data sets. And so there's a GitHub that I use to find data sets for that.
Great, thank you. And Ajay, where do you find data for the projects that you're trying to localize?
Yeah, so in this, to be honest, in this version, we didn't localize much, and I think that was reflected in a couple of the interests from students to actually localize. We also in Rochester, for some of our other courses, we have worked closely with the city of Rochester. They actually have a data portal, and so that's been one of my sources, both at the city level, the county level, and also from the state level data sets. And then that's more for sort of more local data. And then beyond that, it's mostly been Google searches, Kaggle, and also I found some very interesting data sets about transportation, something I've been personally interested in from the Department of Transportation website, the US DOT.
Thank you. There is a question to Justin. Is Java course helpful, I guess, for DS course major? As I see most of the mathematical models in DS courses are Python based.
Is useful for the data science major in general. Yeah, I mean, yeah, right. So right. So DSE 80, like I say, is kind of our course where we use sklearn, introduce students to the idea of a modeling pipeline and so forth. So in that sense, DSC 10 which is our data 8, is a great introduction to that course. So we build upon DSC 10, and just, I mean, all of the ideas of like, you know, these hard to grasp, maybe in theory, ideas like the bootstrap, seeing them run empirically. I think it's a great introduction to those more advanced ideas.
Yeah, and Matthew is asking, did the students using baby pandas run into trouble trying to apply other pandas recipes from Stack Overflow?
Yeah, but that's kind of a feature, right? Because like we want to encourage people to read the documentation, but not necessarily to copy and paste from the documentation. And so if you Google and find, or if you find something on Stack Overflow written for pandas, it may not work in baby pandas. And so, so yeah, I view it as kind of a feature.
That's amazing. Prevents choosing in this class. I think with that being said, those are all the questions our attendees had for the I want to thank you all for presenting today and sharing your experiences, your insights on teaching data aid at your respective institutions. Thank you so much. And at 3:30, we will come back for lightning talks. I would encourage all of the attendees to join us at 3:30 p.m. Thank you so much for attending this session.